This last section on probability is probabilities using counting methods. So this section is going to combine everything we've done so far. It'll look at counting methods, it'll look at probabilities, it'll use all the combination of words that we had before, so I really want you to pay attention to what's going on. It will be important to decide the type of counting method we are using before you start to formulate the probability. The wording should help you determine when to use combinations, permutations, or the general counting method. Also look for clues like and, or, at least. All the things that we've done in the past, we'll just move on into this last section. There aren't going to be any new formulas, so hopefully that's good. But we are going to be joining together the ideas from previous lessons. So I'm going to do a lot of examples to help you see how these ideas are used together. Hopefully you noticed that this said part 1. I broke this into 2 sections, or to 2 videos really, because it was going to be really long if I did just one. Make sure you watch both. You probably will get stuck on the homework if you don't go through both of my videos just to see all the different kinds of questions I can ask you. Alright, so let's start. My first example says, a coffee shop has 14 employees, 8 men and 6 women. 4 are selected to open the store Saturday morning. Find the probability the 4 selected are all women. Okay. So for this scenario, we need to find the number of ways to select 4 women and then divide that by the number of ways to select 4 people. We need to first see that this problem involves combinations. When we're doing our selection, we're not going to replace the people, and the order that we choose the people doesn't matter, so that makes it a combination. Okay. So let's start with the denominator. We have 14 people altogether, and we're choosing 4, so I'll have a combination of 14 choose 4. And then in the numerator, I'm looking at how many ways can I select 4 women. Well, I need to remember there were 6 women in the group, and we're picking 4, so it's 6 combination 4. Okay, so I put the numerator and denominator together. The numerator turns out to be 15, and the denominator is 1,001. I could write this as a decimal, which is 0.015, or 1.5%. Throughout this section, I do use percents and decimals a lot because I think it means a lot more to you. So I want that number value to be important, that when you see 1.5%, you go, like, that's not a very likely thing to occur. Okay, so let's try this again, but this time let's just change the scenario to be select all 4 employees that are men to open the store. Alright, so the denominator is not changing. The scenario is the same. We're picking 4 people, but the numerator does change because now we have 8 men and we're picking 4. Okay, so here's our new probability. So the probability of getting all men, the numerator reduces to 70. When I put it in my calculator, the denominator is the same. But again, as a decimal, I can see it's 0.07, which is 7%. So let's try one more time, but this time let's select 2 men and 2 women to open the store on Saturday morning. Okay, again we have the denominator, it's fine, it's 14 choose 4, but the numerator is 2 men and 2 women. So I want you to think about this word and. What am I going to do with it? So I look at the number of ways to select 2 men, that's 8 choose 2. The number of ways to select 2 women, that's 6 choose 2. But because we have the word and, what do I do with the ways to select a man and the ways to select a woman? I multiply them. Okay. So 8 choose 2 is 28, 6 choose 2 is 15. So I have 420 in my numerator, 1,001 in my denominator, which comes out to 0.42 or 42%. Okay. So let's change our problem. Let's say we have a flower shop, and it has 6 white roses, 4 pink roses, and 5 red roses in a vase by the cash register. If 2 are selected at random, find the probability that neither are white. Okay, so let's start here. I have 6, 4, and 5. That makes a total of 15 flowers. So when I look at that, I have to say, well, of these 15 flowers, 6 were white, and 9 were not white. So I kind of jumped to the bottom of the screen real quick. But this will help me just to know what's my total number and then to look at my scenario. So the number of ways of selecting 2 that are not white means I'm selecting from these 9. And then just how many ways can I select 2 flowers means I'm selecting from the 15 in total. So here's what I have. I have probability of picking 2 that are not white, is from the 9 that weren't white, and I picked 2, so they were pink or red, that's where the 9 came from, and then the 15 in total, and I choose 2. So 9 choose 2 was 36, 15 choose 2 was 105. Putting that in my calculator, I got 0.343, which is 34.3%. Okay. So let's change it and say, well, what's the probability that at least one of the flowers is white? Careful, remember this phrase, at least? At least always says use the complement rule, right? So at least one means either one of the flowers is white or both of the flowers are white. So the easiest way to answer this is that complement rule. The complement rule would be the opposite. So the opposite of one of the flowers being white is that neither of the flowers is white, which was the answer to our previous example. So we already know the probability of selecting 2 flowers that are not white is 34.3%. That means the probability that at least one is white is 100 minus 34.3%, or 65.7. So I want you to look at this, make sure you're really grasping what's going on here. I have a 34.3% chance that I don't get a white at all. That means the rest of the ways to pick involves a white, right? If this doesn't, the rest of them, 65.7, involves a white. So I want you to be careful of this word at least. We've talked about it before, but it's one that I just need to remind you over and over again. So you just kind of like, as soon as you see that phrase, at least underline it, tell yourself I'm using the complement rule so you know that you what your strategy is here. All right, so here's a you try. Change the scenario again, but this time I gave you 15 students in a literature class. They were assigned a novel to read. 9 of them read it, 6 of them didn't. We're going to select 3 at random. I want you to A, find the probability all 3 read the novel, and B, find the probability all 3 of them did not. So give yourself a couple minutes, pause the video for sure, write it out, make sure that you're going to get the same answer that I get, and come back and check it. Okay, so let's see how you did. All right, so the probability all 3 of them read the novel. Well, we had 9 people that read the novel, and we're selecting 3, so 9 choose 3 is 84. And then on the bottom, I have 15 students in the class, and we're choosing 3, so 15 choose 3 is 455. When I divide 84 by 455, I just wrote it out as 18.46%. You could have also wrote 0.1846. That's fine. On the test for sure, I'll tell you how many decimal places I want. Don't worry about it. I know I switch sometimes in the video, but I will be very, very sure to tell you what I want every time so that there's no guessing for you. Okay, so part B. Part B said find the probability all 3 of them did not read the novel. Okay, so I had 6 of them that didn't read the novel. So there's a combination of 6 choose 3. And the bottom's still the same, the 15 choose 3 from the course. So 20 over 455 comes out to 0.044. So I wrote it over as 4.4%. Okay, so there's the end of part 1. Make sure you watch part 2 before doing the homework so that you see all the different kinds of examples I have.